going to explain path homotopic examples of two paths are path homotopic, or some examples of two paths are non-path homotopic. Let's say X is a topological space R2 minus 0 comma 0, and there is a path homotopy from I cross I to R2 minus 0 comma 0. Let's say a path f of s is equal to cos pi s comma sin pi s. As we know that the definition of path is a continuous function from I unit interval to topological space such that f of 0, if we substitute f of 0 is equal to x naught, is the initial point of the path, and if we substitute f of 1, we will get x1 is the final point, terminal point of the path. So here is a path x starting from x0 to x1. So if we substitute f of 0, if we substitute s is equal to 0 in this path, so we will get cos 0 comma sin 0. Cos 0 is equal to 1 and sin 0 is equal to 0. So we will get this point. This is x0, initial point of this path. If we substitute s is equal to half, so we will see that cos pi by 2 comma sin pi by 2, cos pi by 2 is equal to cos pi by 2 is equal to 0 and sin pi by 2 is equal to 1. So we get this point is 0 comma 1 and here, and this is the path. If we substitute s is equal to 1, cos pi, sin pi, cos pi, as we know that cos pi is equal to minus 1 and sin pi is equal to 0. So we will get this point 1 comma 0. So here is a path starting from 1 comma 0 and end at minus 1 comma 0. Let's say one more path g of s is equal to cos pi s comma 2 sin pi s. So if we substitute g of 0, s is equal to 0, so cos 0 comma sin 0, 2 sin 0, cos 0 is equal to 1 and sin 0 is equal to 0 and 0 into 2 is equal to 0. So we will get this point again 1 comma 0. If we substitute g of half in the place of s is equal to half, so cos pi by 2 comma 2 sin pi by 2. Cos pi by 2 is equal to 0 and sin pi by 2 is equal to 1 and 2 into 1, 2. So we can see that this point lies here 2 comma 0, 0 comma 2, and there is a curve from here to here, starting from here and end at here, and not this is the middle point. So if we substitute g of 1 at s is equal to 1, so cos pi and 2 sin pi, cos pi comma 2 sin pi, cos pi is equal to minus 1 and sin pi is equal to 0, 0 into 2 0. So we get this minus 1 comma 0, again this point, terminal point. So we can see that this is the two path f of s and g of s are path homotopic. If we replace the value of t, we can translate one path, we can continuously deform one path into another path. If we substitute t is equal to 0, we will get first path this, and if we substitute t is equal to 1, so we will get this path. So we can continuously deform into one path into another path. This is the path homotopic. This is a path homotopic example. Now I am supposed to now I am explaining non-example of path homotopic. Non-example of path homotopic. So let's say f of s, the previous function, previous path, continuous function cos pi s comma sin pi s, and another function h of s is equal to cos pi s comma minus sin pi s. And path homotopy, there is a path homotopy exists from I cross I to R2 except for region 0 comma 0. So if we substitute f of 0, we already saw that cos 0 comma sin 0, and we know that this cos 0 is equal to 1 and sin 0 is equal to 0. So there is a diagram. So we get this point 1 comma 0 is the initial point of this path. So if we substitute f of s is equal to half, so cos pi by 2 comma sin pi by 2. Cos pi by 2 is equal to 0 and sin pi by 2 is equal to 1. So we get this point. There is a path. If we substitute s is equal to 1, so cos pi comma sin pi. This is the answer. So cos pi is equal to minus 1 and sin pi is equal to 0. So this is the point, terminal point of this path f of s. This is the first path. Now I am going to another path h of s. H of s explain here. Cos pi s comma minus sin pi s. If we substitute s is equal to 0, so cos 0 comma sin minus sin 0, cos 0 comma minus sin 0, cos 0 is equal to 1, sin 0 is equal to 0. So this is the initial point of this path. If we substitute half, s is equal to half, so we can see that cos pi by 2 minus sin pi by 2, cos pi by 2 comma minus sin pi by 2. Cos pi by 2 is equal to 0, sin pi by 2 is equal to 1, and minus 1 is minus 1, minus into 1 is equal to minus 1. So this is a point here. If we substitute it, s is equal to half, so we get this point. If we substitute s is equal to 1, so cos pi comma minus sin pi, as we know cos pi is equal to minus 1 and sin pi is equal to 0. So minus 1 comma 0 is the terminal point of h of s, the second path. So we can see here two paths h of f of s and h of s, and this is the path homotopy, we explained it here. But we can see that this path is not continuously deform into this path, or either h of s we cannot continuously deform into h of s, because if we will reach here, we cannot cross this path and at here. And if we take f of s this path and going towards the h, but we cannot cross this, so this f of s is not path homotopic to h of s. Thank you.